Hey, hi everyone. So I hope I am audible. I am Arun. So probably you may know me from MLF and MLT course. So welcome to deep learning. So you made it. So what are we going to do in this session? Yeah. So I shared the screen. I hope it's visible. So is that visible?
Yes,
Yes, sir.
Yeah. Thanks. Oh my God, I forgot to name it. Okay, so this is the agenda. So first I would like, since we are very few, right, around some 55 learners. Out of this, I hope some of you have joined the session. So let's get to know each other. Let's share, just briefly introduce about yourselves. What are you doing, all these stuffs. And then we go into the course content, and finally we discuss something about the course. Maybe if you have doubts, we discuss about that and whatever. Okay. Yeah, so shall we go by alphabetical order or any volunteers? I think no need to share the screen. Yeah, Susmita Saha. So I am going in the order that is displayed on the screen. Hi, Susmita. Sorry, Sumista.
Yes.
Sorry, if I mispronounce your name, please forgive me.
No, I should. Good evening.
Yeah, good evening. Yeah, can you introduce yourselves, Sumista Saha? So over the course of time, I hope I know all of you.
Okay. So myself, Shumishta Shaha. So I am from West Bengal. So I completed my mathematics honors in year 2020 and currently doing this IITM online PhD degree course for full time. So actually I completed all diplomas and that's why I am in my degree level. Apart from this, I am doing a data science internship in RNTBCI and also I am a Python mentor in IITM online PhD course. Apart from this, I am also a group leader in Kanha House Divided 2.
Oh, that sounds great. So you are from math background. Your major is in math.
Yes, sir.
Oh, it's difficult for me to handle. Oh, God. Okay, it's a challenge. Okay, thanks, Sumista.
Thank you, sir. Thank you.
Yeah, the next one. So I think it's better to lead the last name. Laha, Saha, and Laha.
Yes, hi sir. Good evening. So I am Dibyendu Laha, and I have also graduated with math honors, and currently I am only doing this degree alone.
Okay.
Yeah.
So you are not working now. So you are.
I am. Yeah. So I am only doing an online means remote internship only. That is.
Okay.
Yeah. On Goovi, I am doing that. Yeah.
That sounds great. Okay, welcome to the course.
Thank you, sir.
Yeah, Himanshu. Yeah, first you pronounce your name, then I store it in my mind. Next time I try to.
sir, my name.
Yeah.
So my name is Himanshu. You pronounce it right.
Oh, that's great. Okay. Yeah, hi,
Like,
Himanshu.
is that?
Yeah.
Hi, sir. Is that hard to pronounce?
No, it's fine.
Okay.
Himanshu. Yeah.
So, yeah. So apart from this degree, I am doing CSC at my college. I like hardware, like ray tracing kind of stuff. So very geeky.
Okay.
So apart from computers, I am also interested in quantum mechanics, something that is related to computers, but not really.
Yeah, quantum computing is there. Somehow you can jump into that field.
Yes.
Yeah, that sounds
And yeah.
okay. Thank you, Himanshu. And Trivikram.
Good evening, sir.
Hi, good evening, Trivikram.
My
Your
name is
name. You pronounce your name first.
Arun, sir. My name is Trivikram Manath. I live in Mumbai, born and brought up here. And
You said from Trivandrum, right? I think I'm not sure. Okay, please go ahead.
Yes, yes, the name originated in Kerala. So
Okay.
it's actually named after the fifth avatar of Vishnu, Vaman avatar.
Okay.
So that's how the name is derived, Trivikram. But yeah, I think it's a very unique name. I'm blessed to have it. So I've been born and brought up in Mumbai.
Okay.
For the past 2 years, I've been doing this. I've been doing BSc degree from IIT Madras, and I've also been working in Larsen and Toubro Infotech as a software engineer in ERP systems and SAP.
Oh, that
So
sounds great.
I joined my first job and the second degree almost at the same time.
Yeah.
Before that, I've done my BTech in electronics and telecommunication.
Oh, you
From
are from EC background. That's great. I am also from EC background, electronics and
yes,
communication. Yeah.
yes, it's the most versatile background of engineering.
Yeah.
People of EC come and do anything.
Yeah.
That's
So you feel comfortable with the course, I guess. I mean,
Sorry,
throughout the you feel comfortable with all the math stuff, I guess.
I love math. I love math.
Yeah.
I love anything that has math in it. In
Oh,
fact, I intend to even do speech technology after some
nice.
time. I've taken a bit of a lesser course because I want to prepare for GATE and try for masters. So that's the plan.
Yeah, that sounds great. Yes. So if you have math interest, of course, you must do higher studies.
Yes.
Okay.
Thank you.
Thanks, Trivikram. Hey, hi, Aditya Raj.
Yes, good evening, sir.
Good evening.
Sir, myself, Aditya Raj. I am from Bihar, and currently I am doing degree level. Uh, and apart from this, I am also doing a PSc in mathematics.
So you are also from maths background. Oh my God.
Yes, sir.
Okay. That
And,
sounds cool.
apart from this course, I am doing a coding, completing coding.
Okay.
Yes, sir. And I'm looking for placement internship.
Okay. Thanks. Thanks a lot, Aditya.
Okay, thank you, sir.
Yeah. Hey, hi, Govind.
Yeah, hi. Good evening, Arun. I'm Govind. Actually, I'm a working professional. I am employed
Pleasing to hear.
at Infosys Limited. I work out of Hyderabad. I'm a technology architect in Infosys.
Wow.
So I'm mostly into software development and architecture on enterprise application integrations. So I happen to have little bit of background in deep learning because earlier I had listened to some of the lectures from Professor Mintesh Kapra as part of NPTEL program. So that is a simple background I have, and I'm looking forward to pursue this course to the end of this program. In the sense, like I want to complete the degree, and maybe I'm looking forward to go further in this program.
Wow, that sounds great, Govind. So happy to see that you put an enormous amount of effort to come up to this level.
Yeah, thank you very much.
Yeah.
And I see familiar names in the list, participants whom I have seen them in the previous live sessions. It's good to see them as my classmates.
Yeah, that is, I mean, I was about to ask that question. So how many of you know each other, right? So it's a kind of online.
Personally, maybe we don't know, but from the participant list, these names appear quite often in the live sessions. That way, it is pleased to see all of them.
Wow.
Thanks.
So do you have any groups for each course, or some kind of WhatsApp group or something like that, or you all work alone in all sort of things?
We have this course.
The way this program is structured, I think we just meet only in the online sessions.
Yeah.
But people are free to form their own groups. But there is no course-specific group in which people can collaborate and participate. Except, I think recently, I think for the other courses they created this WhatsApp groups. Otherwise, there is no official channel for all of us to meet and interact.
Yeah. So especially, when the enrollment is really high, then maybe forming a group might be not a good idea. But in degree level course, I think deep learning and artificial intelligence, I think around 55 students enrolled in both of these courses. Yeah. So anyhow, let's see whether we can form a group and discuss something interesting there.
Yeah, I think that will be better. I think we can have some chat on some advancements also, maybe share something across, and probably
Yeah,
we can.
for deep learning, if you want to share the advancement, I think for every second you have to put a message there, because it's growing very rapidly. I mean, so something that is so adapted by the industry. Now there are so many new things. It's every second it's keep growing. But that would be interesting. Maybe we can share some interesting articles or whatever interesting links. That might be the channel might help in that perspective.
Yeah, exactly. Yeah, right.
Yeah. So okay, now 3, 2, 1, 6. So we know each other. I don't know when we are going to know all the 55. Maybe in the next live session. So maybe I form some WhatsApp group, and if you have the contacts of other students, you can join them in the group. So we can have some discussion over there. Probably not all of them are comfortable in joining. Not comfortable. Maybe they don't find time to join this live session. Okay. So now we all will take the degree together soon. Yeah, the first batch, always a golden batch. Yeah. Okay, so now just I would like to hear about the course content. So we are in week 2 now. So you might have watched all the videos of week 1 and week 2, as well as assessed all these assessment questions. So I would like to hear a feedback from each of you. So what do you feel is the content satisfying to your expectation? So that kind of whatever the feedback you have in your mind, so you can share it now. And if you want to make any course correction, of course we have done up to week 5. So after week 6 we can incorporate all your suggestion and try to make some better content. Again, should we go name by name, or
Yeah, I can start. I think the course, the content delivery is very good, because as I said, I had opportunity to listen to some of the professors' lectures earlier. The way he actually organizes the slides and the way he actually takes through the concepts is very good, actually. And especially this set of content, I don't know whether it is recorded again. It is little different from whatever is there online in NPTEL program, and it is more practical oriented in terms of a little bit of touch on the actual programs to be written. I think that is good in that way. But coming to the problem solving, I happen to actually, as I said, give NPTEL exams on deep learning also. So the challenge I mean, I don't know it is a challenge or not. Probably will overcome it eventually by attending the complete set of sessions. I think little bit of hand holding, maybe I don't say it is hand holding, practice should be is required in terms of solving problems related to network construction, right? So there are some problems which are in the assignments. So we got to see just 20 problems in 2 weeks, right?
Yeah.
So little bit of exercise or exposure to different kinds of problems for the network construction, basic network. Like for example, there were some questions in terms of how do we formulate a perceptron on a network to solve this kind of a problem, right? Are there any techniques, or is it always brute force, right? Is it like always we have to enumerate all possibilities and come up with the thresholds, or are there any techniques in constructing such such networks by hand? And that kind of insights may be helpful to actually consolidate the foundations.
Yeah. So yeah, that's a good point. And I hope you are all visiting actually the Mitesh Kapra's website page, right? So maybe I will share the link in the discourse, and I will ask each one of you to visit that site. So the reason is whatever the reference we follow, sometimes we can't include all the stuff from the references into the slides, but we always refer to those references because there are more information on those references. So especially when we consider this week 1, week 2 content, there are some books which we actually follow. Maybe I will share it here, or you can visit that site, Hitesh Kapra's personal site. So you can follow that reference as well. Yeah, so it's there. So yeah, as far as this week 1 and week 2 contents are concerned, so all of them, especially if you really want to build any Boolean functions using Perceptron, of course you can come up with the threshold values by just explicitly writing all the equations for the Boolean functions, and you can come up with, of course, there are no specific solution, single solution. There are set of solutions. So in such a case, maybe we need to give you a hint which solution we are looking for, something like that. And as far as this problem solving is concerned, so I thought we always the practice questions, and if you are stuck at specific practice questions, right, I need more help on the practice questions, then we can share some more problems around the practice questions, so that when you are able to solve that, you will be eventually able to solve those practice questions. I think that will be a good idea, because as I observed in the previous courses, right, so instead of giving you more and more questions, all types of different questions where you may feel exhausted, maybe some of you, it would be much better idea if you are get stuck with some problem, if you are not able to make any further steps, then we may construct a problem around that problem and then hand over to you, and maybe help you around that problem by giving another example. I make note of this.
So one thing in the first week is that treatment of inhibitory inputs, right?
Yeah.
How do we actually treat them in formulating the equations and probably solving? Maybe that could be. Maybe I face a little bit of challenge around it.
So it's about the graded assignment, I guess, right?
No, in the lecture also, I think there was a brief thing about inhibitory thing.
Yeah.
But specific, we did not go through formulating the equations and solving. We did it for the simple case in terms of thing, but for inhibitory thing, probably we didn't do. And
I think there was a question in the graded assignment that is asking about you to implement this formally. We just mentioned that if the inhibitory input is on, then the output is 0. But how do you bring this into an equation? So for that, we framed a question around this concept, and I think there is one question in the graded assignment. Of course, we talk about this after hearing the opinions or feedbacks from the rest. Thanks, Govind. Thanks for coming forward and sharing your thoughts. Yeah, any other thoughts about this course? So Govind might feel much comfortable with the course because he has already taken this course. Only some 30 to 40% of the content will going to be deferred. Any other thoughts? I think you can just unmute and say the course is good. So that will be much pleasant to hear. And also, I'm not seeing so many questions on the discourse. Like maybe just it's about 55. Or there are two possibilities. Either you understood everything and the course flow is nice and you are able to follow up the questions, not much doubts. Yeah, Aditya, I think you unmuted yourself.
Sir, I want to ask from when we are going to do some practical stuff in deep learning.
Yeah, so you are asking about in this course or in the entire degree program?
In this course.
In this course, we are not actually going to go into deploying deep learning models. By the way, it doesn't mean that you will not be able to do that. So with the help of the frameworks, of course, you can develop any architecture with few lines of codes. It's not going to be that much difficult because most of the time, I mean, you already have an exposure to machine learning practice. You learn practical techniques like cross validation and choosing a samples,
Yes,
all
sir.
these stuffs. You can do the similar stuff with deep learning frameworks, but some of the doing some stuff like if you want to construct, say for example, if you want to implement ensemble method on deep learning, that's not going to be, possible in deep learning. So I would say if you really want to implement the architecture parallelly, I mean, say if you want to really develop an application, say for example, if you really want to recognize some image, it's a cat or dog using ConvNet. Maybe I think ConvNet will be introduced in week 7. So after learning how the ConvNet works, then once you understand the entire operation, then you can simply write 3 to 4 lines of code in the framework. I even promised, I'm thinking about creating a collab on each of the architectures so that you can simply go through the collab and execute, and it won't be more than 40 to 50 lines of codes, even the entire thing, importing the library, setting the data, creating the architecture. So everything is going to be within 50 to 60 lines. That's what I would say. So I share the collab. You simply go through it and execute it. You will understand the entire structure. It is like almost like a, kind of a scale and stuff.
So Arun, we in learning sklearn, I think we had put in effort in terms of coding ourselves, spending some time with the API and get building the muscle memory. Will there be that kind of introduction to any of the frameworks in this course?
No, we are not formally, introducing, from the grading perspective, it's not going to be any sort of stuff like that. So we just introduce, and of course, there are two major frameworks used for deep learning. One is PyTorch, the other one is TensorFlow, and then Keras. So we introduce PyTorch, but not the entire components. Not from the scratch. It's like kind of we give you the code. Again, it's not part of any grading policy, but just to have a hands-on experience, right? So how these architectures really solve the problem, we just give you the collab that I am planning to create one, because to make, learning theory is one side, but unless we have some practice, we may not feel satisfied, right? We don't get full satisfaction. So that's why I'm thinking of creating the collab. It's not a difficult thing, but we are not introducing, not introducing, right? So we choose PyTorch, but we are not going to cover everything about the PyTorch. So I just hand over you the collab and walk you through the code. You need not to even understand everything in one go. So you can, experiment everything on your own based on your time. So that's the plan. In fact, we are thinking about offering deep learning practice course, but I'm not sure whether it is going to happen soon. Even in deep learning practice, we are not going to focus on creating the architecture. So we are going to focus on optimizing the hardwares for the given architecture. That is an idea, but to implement the architectures, as I said, we release the collab and you just go through it. That is more than enough. And if you really want to know about the framework, then it's self-learning. So you can, I think the tutorials and the documentation, everything is well documented. So anyone have an idea about the deep learning can refer to those documentation and walk through those tutorials. That will be more than enough to create any architecture to implement it.
Okay.
Sir, can we implement some basic papers regarding deep learning?
Sorry, what do you mean by basic papers? You mean research paper?
Yeah, so which are not that high in topics, but which we can understand. So I think that would be better because going through research paper is not something that one can do very easily at this point.
No, still not able to get your point. So, say for example, there is an architecture called ConvNet, which was proposed in around 1990s. So you are kind of asking, can we implement that paper from the scratch, something like that, without using
Yes.
frameworks?
Yes, exactly.
Without using frameworks, it is going to be a tedious task. I'm not saying it's a difficult task. So you will see this week 3 content is about artificial ANN, which you already studied in MLT, but not in details. So that is what feedback I got from Karthik. You have an idea about ANN, you have an idea about backpropagation, but you didn't really implement a backpropagation. I think, how many of you have taken a look at week 3 contents? Can you raise your hand virtually? No one?
Just went through the table of contents.
Yeah, so it's a kind of a warning signal now. Okay, so week 3 is going to be tough. Though you already know ANN, writing a code for, writing a backpropagation algorithm is of course easy, and but it takes a lot of time to understand the entire process, because there you will see lots and lots of equations. And Professor Mitesh also mentioning everywhere that don't get intimidated, try to work out, pause this slide, work out all these stuff. So once you are able to write a backpropagation algorithm for an ANN, then that is more than enough to, what I wanted to say is that once you are able to write backpropagation for ANN, you can write backpropagation for CNN as well. It's not going to be that much difficult. So instead of relying on and writing everything from scratch, because there are many chances that we might make mistakes while do backpropagation, because apart from this theoretical knowledge, we also need to ensure, caching all the intermediate outputs. Okay, so especially when deep learning is considered. So I would rather say, thinking about implementing the deep learning models from the scratch is quite unnecessary, even with respect to research. Okay, I think no researchers are implementing everything from the scratch. Once you implement ANN algorithm from the scratch using, backpropagation for ANN from scratch using NumPy alone, that is more than enough to guarantee that you understand everything in detail. Okay, so I'm not preferring that one, but if you are deliberately want to implement everything from the scratch, I would be happy to join with you once you implement this ANN architecture.
Okay, so by scratch, I didn't mean like from zero. I meant using something, some frameworks. But I think like once we implement something at a deeper level, like apart from just model and then fit and then
Yeah.
predict.
So I got your question now. So it's a kind of in sklearn stuff, we just call 3 lines of code and call fit, then everything is done. So you are asking something not like that, right?
Yeah.
Yeah. So in deep learning frameworks offer you 2 possibilities. So one is kind of sklearn style, where we can create the entire network with very few lines of code. You create a class, then put all the methods like forward propagate, back, even back propagation is taken care by the architecture, by the framework. The other style approach is to use low-level API, like you do everything kind of from scratch. Okay, you take care of everything instead of leaving this to the framework. You take care, you pay. You implement everything from scratch using the functionalities from the framework. We can do that. That is quite good, but we may take this as a kind of, not part of the course, but kind of homework assignment, something like that, non-graded assignments. Okay, I keep this in mind and try to come up with a better approach. So whoever interested may use this low-level APIs to implement the architecture from the scratch. That's really a good idea, because what is that link Himanshu shared?
Yeah. So where my question was motivated from is 2 sources. First, Fast.ai announced yesterday that they are doing a course where they will implement stable diffusion from scratch. I don't know how much scratch, but from scratch. That is what they
Okay.
announced. And
I
second,
think they
this
have their
week,
own API, I guess. Which framework they are using? I think they build their API on top of PyTorch, if I'm not wrong.
so I exactly don't know but they just announced that yesterday, and they will offer that course in early 2023.
Okay.
So there is a lot of time for that one. And two, the link that I just posted is from Andres Karpathy. He was chief model engineer for Tesla. So he was their main guy for AI.
I think he resigned from Tesla, if I'm not
yeah,
wrong, right?
yeah, he resigned. Yes, he resigned, and now he put this awesome YouTube videos where he implement things that he created.
Yeah.
Yeah, from scratch. So this is where he used his back propagation tool.
Yeah, in fact, there is a site. I mean, he taught this deep learning course, I think at Stanford around 2015 or 16. So then it became very famous. So I think you can also follow his blog where he implemented everything. Not implemented, in fact, he has posted some pseudo codes for every algorithm. So we can at least look into the code and try to reproduce.
Yeah, also he was he had this visualization support, convolutions and all, right? He was part
Yeah,
of Stanford team of, I think the ConvNet that won the 2014 or 15 competition, I think.
Yes, you are right. So, I mean, first, he is a great teacher. So if you look at his lectures, of course, he is very fast. You have to slow down and listen to each of his words. It takes some time. If the lecture is 1 hour, we may need to think about 3 to 4 hours to understand what he actually conveyed. And his teaching style is also really good. So, of course, we all should follow Karpathy, Andrew. I hope you are all following. You might be following all these legends, Jan LeCun. Jan LeCun is very active in social media. And Rich Karpathy is also very active in social media like Twitter. And also, yeah, there are many like Steinman people are there. So make note of it and follow them. So you will know the recent. There are, the field is growing very rapidly. So very difficult to keep pace with such a rapid, developments. So instead, if we follow them, maybe we may figure out which area we need to actually focus, which is interesting to us. So that's really a good idea, I suppose. And thanks, Himanshu, for sharing these videos. So I watch them and see whether we can do something somehow able to relate those with the course.
Okay, no problem. Sir, what was the last name you took? I couldn't get that.
Sorry, lost name. Lex Freeman. So, so you can just type it in Google. LEX.
I got it, sir.
Yeah. Of course, there are many, in fact, but these people are kind of very active in the social media. Yeah. Okay. So thanks for the feedbacks. And Sumista and Laha, do you have any feedbacks, or we just move on to the next topic, that is discussing about the questions?
Yes, sir. Go on.
Yes, sir. Yeah, since I am doing this course totally new, I don't know anything much about, and I don't think I can give videos. Whatever till now I have watched the videos that are good and interesting for me, and that's all I can say.
Okay. Okay. So I hope you are joining the subsequent sessions as well. So that and also encourage others to join. So how do you know any people other than these 6 who have opted this deep learning course as well? Do you have any idea?
No, we don't have any.
No,
Because
sir.
Oh, this is very sad, right?
no, basically that is how this course is, right? Unless we start the course and we see our classmates in the participant list, there is no way we can know who's taking the course.
Yeah, that's fine with the, foundational level, even at the diploma level. But at the degree level, I think we are just 55. So we must, okay, let me create the group and invite all. I have all the contacts. I hope the team must have all your contacts. So I send an invite to them so we can join.
Yeah, even I felt the need to be connected in the ML practice course, right? Of course, the forums are there, but probably just to bounce an idea and probably to get the feedback, that kind of thing. To actually start active conversations. These things help in increasing the pace of learning, I think, instead of just waiting for the lessons and listening to them and solving the problems.
Yeah, that will be really, at least with 55, right? We have to do that. And then we have to think about how to scale it up, but we can at least experiment. We must all join together. So I create a group and I'll send you an invite to all of you.
Yeah, sure. Thank you.
Maybe in the next session will be an kind of introduce yourself session, maybe.
Yeah. So will there be only once in a week interaction like this, or it will be more than once, or what is the plan? Because in the degree level, I do not see any invites for other courses as well. No sessions are set up for the AI also.
Yes, you are right. So the perception or the expectation from the students who have crossed the diploma level is that they are well equipped with all the required prerequisites. So from the degree level onwards, they should stand on their own. Because I'm sure once you are good at maths and MLP and MLT for this course, then you have to, if you think on your own, right? So maybe you can grasp all the contents quickly. You have small doubts where you can post it in the discourse and get an answer for that. So the majority of the people, right, voted for this. So on the degree level course, even for deep learning course, we skipped this activity questions. I don't know whether it is there for AI and other courses. Do you see activity questions in?
No sessions are set up for any other courses. I think you are the first person in this program to actually initiate a live session so far. I think yesterday there was this session on the strategies for professional growth thing.
Okay.
But otherwise, there's no other session planned in the sense in the calendar. The calendars are shared, but there is nothing in the calendars yet except yours.
Okay, so so in the videos you are not seeing the activity questions, right? Or you are seeing an activity questions in other courses?
So for speech technology, there was activity questions for 1 week, first week, but they removed it for second. So I don't think so there will be any. Yeah. So activity questions are dropped off, and of course, as for this other sessions like solve with instructor session, right? That is also dropped off. And we must have one interactive section for the reasons that if you are unable to solve something, we are expected to, but even if you are unable to solve that, I hope there must be at least one session to discuss anything on the course, be it solving a problem or whatever the difficulties you are facing in the course. So I think there will be at least one session for the course. I'm not sure about, but for deep learning, we are planning to have one. But if students face many difficulties in any one of the week's contents, maybe we arrange, on-demand session. For week 1, week 2, I hope everything is going smoothly. Week 3, I hope maybe we need one session. It depends. So you watch the week 3 videos, and it's not really difficult. It seems it is going. You may perceive it too difficult at the first sight, but if you really think about it, it's not actually a difficult one. But from given the past experience, even with the IITM students, it seems that many struggle with this backpropagation algorithm. Oftentimes they ignore it, right? So what the framework implements it, so why should I focus on it? But Mitesh sir is very strong on this point. Someone
I mean, we should be in a position to implement back propagation algorithm for at least for artificial neural networks. I mean, in general, fully connected. Given you, it's a kind of creating a small function where you feed in all the information like a scale and for how many layers and what is the activation function, all these stuffs, and then it must produce the result. It should converge, right? So this setup is necessary to really, which is going to be really helpful when you learn ConNet or whatever the architectures in deep learning. So week 3 is going to be a little difficult. So if you need an on-demand session, of course, we can arrange one to clear your doubts. So I follow the discourse, and if you post it there, then we arrange one. No worries. If there are no questions from the, I mean, if you feel comfortable with week contents, I think one session per week is sufficient, especially on Saturdays. I suppose on Saturdays you are all free. Not free in the sense you may have some work, but you will be able to attend the sessions, most of you.
So will it be from the same time, 7 p.m. or?
Yeah, I am thinking of keeping it at 7 to 8 p.m., giving the comfort of the students.
Okay, sir. No problem.
Because from the past we hear that 7 to 8 works for many. I mean, they come home, get refreshed, join the session. I'm not sure. Maybe you, of course, if you feel that the session timing should be shifted 9 to 10, something like that, I'm happy to do that. Again, the majority wins.
This time will be helpful, and if we have some more doubt, we can extend the timing also. Like
Sorry,
7 to 9.
Mr.
So this time is fine, Saturday.
Okay. Okay.
So also, if you have some more doubts, then we
Okay.
can extend the timing like 7 to 9, right?
Yeah, that's for sure. So of course, I reserve time from 7 to 9. So even if it go beyond that, we should be. I mean, I'm okay with that as long as you are comfortable with that.
Also, sir, in software engineering, there are activity questions.
Okay. So you enrolled in 3 courses.
No, right now I have 4 courses.
Oh, you are doing 4 courses parallelly.
Yes, sir.
Okay, so you are from math background, so you must be in a position to do that, all of this. Okay, how
That's
many of you are?
Huh?
Yeah, sir, please go ahead.
But these courses are new for me. I'm learning first time here. This deep learning, AI, all these things. ML, programming also, as I am from math background. So I learned programming from this course.
I mean, you have already learned programming, right?
Yes. Yeah.
Yeah, so given you are from math background, you should be in a position to learn any subject. So that is what the common perception. So mathematician must be in a position to learn anything quickly. You have a company as well, I guess. I think maybe I will take a look into each one of your background. How many of you are math major? So I may be in trouble if so many are from the math majors. Because okay, let's see. Okay, okay. Now let's come back to this discussion on assignment questions. So if you have any specific doubts in any of the assignment questions, you can ask me, or I just okay. I think it's a good idea if you have any questions, you can ask me. Otherwise, if you are comfortable with all the questions, and there is no point in going through all the questions and explaining. Do you have any confusions, or you see any ambiguous questions, wordings? It often happens.
Sir, I will say like I don't have any issues, but I will say go through all the questions, because if someone is viewing the recording on YouTube, and
Yeah.
if they have a doubt, so they can clear that out.
Okay, so going through the questions, you mean in both graded and practice?
Yeah, we can start randomly, probably. I have a question on on practice assignment 4.
Practice assignment. I mean, in week
Question
1 or
4.
week 2?
Week 1.
Okay. Okay,
Yeah,
let
week
me
one.
share the screen first. Where is that? Okay, so you are able to see this screen, right?
Yes, yes.
Mm, okay. Fourth question.
So in this, just for the sake of discussion, probably I'll make a couple of statements and then probably we can take it from there. So we said that and the perceptron neuron, right? The perceptron can be used to implement Boolean functions, right? Now Boolean functions we started with some examples on and or, right?
Yes.
Now in Boolean logic, implementing Boolean functions, it is possible for both excitatory and inhibitory inputs, right? In the sense like we take it is basically a representation whether we are putting a NOT gate before input to the AND gate or OR gate or something like that. Why do you have this question? Like, what is the
Motivation.
what is the motivation and what is so specific about perceptrons which will make or make it possible or impossible to implement a Boolean function?
Yeah, so it's not, I think in perceptron we don't have this inhibitory input, right? So it is with respect to this Michaela-Pitts neuron, MC neuron.
Right, sorry. Yeah.
So in MP neuron, say for example, if we take NOT function, right? So if my input is 1, the output should be 0. If the input is 0, the output should be 1.
Right.
So
if that is that is what we are implementing.
Yeah,
right?
If that is the function we want to implement using MP neuron,
right,
then we get stuck with that without this inhibitory input.
Oh, right. So we cannot give a zero input to the neuron, you're saying, without inhibitor.
Yeah, if you said, even if you feed 0 input, I want the output to be 1. So finding the threshold is contradictory in this case.
Correct.
So in that case, yeah.
Okay. So how does this question, like we are saying that all Boolean functions can't be implemented only using excitatory inputs. So we also need inhibitory inputs to implement Boolean functions.
Yeah. So there are some Boolean functions which requires inhibitory input in order to implement that Boolean function. So without it, we may not be able to come up with the function or a threshold that enables us to implement that function. And maybe so in week 2 you might have explicitly seen how many Boolean functions we can have for a given n inputs, right?
Yes, sir. 2 raised to n.
Yeah. So out of how many of them are linearly separable and how many of them are non-linearly separable? If that is the question, so I think that question was left to the students. So did anyone put an effort to find an answer for that question in a general way? So if the input is 2, then we can come up with the numbers. So these many are linearly separable and these many are not. But do we have a formula for that in general for any value of n?
No, sir, there is not.
Yeah. So you are saying no, in the sense there is no such formula.
Yes, we cannot predict that number based on any formula, is what I'm saying.
Yeah, so it is still a research question, right? So I think as the value of it, this is really interesting. So you can really Google it. So as I don't know whether I have shared it. Maybe I share it in the discourse. I think people have found for n is equal to 2, where we have 2 raised to the power 4, 16. So out of 16 Boolean functions, we have 14 are linearly separable and 2 are not linearly separable. So like that, they have found number of non-linearly separable or linearly separable functions for n is equal to around 9. So when when you put n is equal to 9, the count is really huge, but they somehow come up with the numbers. So the number is really huge, by the way. But we still do not have a formula, direct formula, which gives this count. How many of them are linearly separable and how many of them are not linearly separable. This is really an interesting one. I just recalled all these things after seeing this question.
So how do we answer questions like 6 then?
Questions like 6. Okay. Okay, we know that Boolean form. Maps 0. How many linearly separable? Yeah, so for small values of n, we can count it. That is the only way. Okay, we won't go beyond. I mean, this is a kind of explicitly writing all the possible functions and see which are linearly separable. So this is countable and also within a time frame. So that's why the question is.
Okay, so when it is one dimension, then that means there is only one input, right?
Yeah.
So what is linear separability if it is only one input?
That's really a good question. I'm also thinking about it. So linearly separable. So we must come up with a single threshold such that all the outputs on the right side should be equal to, say, for 1, and all the outputs on the left side should be the other class. So it should be a single number, not more than 2 thresholds.
No, in terms of functions. So the question is,
Okay.
how many linearly separable functions are there when n
Yeah.
equals to 1?
Okay, let me share the whiteboard. Let me try to. Where's the whiteboard? Not seeing anything.
No, we are just, I'm seeing only the browser, the Seek portal.
Yeah, I'm trying to find a whiteboard from, I think Zoom has a whiteboard, right?
Sir, you can use Xcalibur Draw.
Sorry, which one?
EX
Yes.
CALI LI
Okay.
DRAW.
Okay. It's a kind of it's okay. So in order to find that answer for that question, right? So we need to recall the definition for linear separability. So what it says. So when do you say a function is in general, the classifier is able to linearly separate these data points. So if you are able to find theta, okay. So if I'm able to find out a function f of x, okay, which returns, okay, so let me take this specific example. So when n is equal to 1, we have 2 power 2 power 1, which is 4 functions, right? Which means if my input is, let's say my input. So when I say n is equal to 1, it can take 2 possible values. So it could be either 0 or it could be either 1. But the function is, first function may produce 0, 0 for both the case. The second function may produce 0, 1 for both the case. And third function produce 1, 0 for both this input, and fourth function produce 1, 1 as an output. So my input space is something like this. How do I, what is that formula?
No, why input, input is, there is only one input, right?
Yeah, there's one input, but the value it can take is 2.
Okay. So the function's output should be the truth table, the function's output should be either 0 or 1, right?
Yeah, say for example, if I take this as one function, so there are 4 possible functions, right? So if my input is 1, the function produce output, sorry, input is 0, the function produce output 0. If my input is 1, the function produce output 0. So this is one possible function for this input.
Okay, that way.
Say for example, even if you consider this AND function that we have discussed in the lecture, there are two inputs, x1, x2. So there are only 4 possibilities with these inputs, right? So 0, 0, 0, 1, 1, 0, 1. So these are all the 4 possibilities if I have 2 Boolean inputs. But the function could be 16 functions, which means for these 4 possible inputs, the function could produce any 4 possible outputs. So each output can be either 0 or 1. So the combination is 16. So 0, 0, 0. This is one such function. You are able to follow that, or it's still hard convinced about this?
I think we are so out of all those possibilities, we are only taking 4 possibilities, and we are calling it as an AND function, is it?
Yeah, so of course for this AND, this is 0, 0, 0, 0, this one must be 1. Yeah, out of these 16 functions, we take one a function and we call it as AND.
Okay.
So if this is the case, which means, say for example, I have to check whether I can come up with a threshold that actually does this job. Okay, so for this function, so if I give input as 0, the output should be 0. If I give input as 1, the output should be 0. So can I come up with a threshold for that? So the question is
-2 or something, right?
Yeah, it can be any number, because the threshold is often is this inequality sign. So for all these cases, we can find a single number that produce all these 4. I mean, for each of these function, we can come up with the threshold that actually produce this output as is.
Okay.
That is what implied in that question.
Okay, now how do we know the linear separability out of its 4 functions?
Yeah, so say for example, if it is 2, say for example, the inputs are 2, right? So we usually draw this picture. Of course, we can use the definition of linear separability, but we can picturize and see what do we mean by that definition.
No, because so it is one input, it will be line, right?
Yeah, it will be a line.
Right.
So even if it is a line, right? So the line is now 0 and 1.
Right.
Okay. So I have to come up with the threshold value such that all throughout this entire line, right? Such that there should be only one threshold, such that it implements all these 4. For all these functions, I should have only one threshold. That is what we mean by, because we can't see a kind of curve in 1D. If it is 2D or more than, yeah.
Correct. Even for the line, there are infinite possibilities, right? I mean, any value in between 0 and 1 can make it linearly separable.
Yeah, say if my input is 0, the output should be 0. So what should be my threshold? Say for example, for my input is 1, the output should also be 0.
Correct. Anything more than probably anything to the right side of the 1 is a possible candidate for that.
Yeah. So there is a threshold 1.
There are infinite. What do you call? Oh, there is a
infinite possibilities. So the theta can be there are of course anything greater than 1 is an answer to this question. So all of them are the proper threshold for this function, right? That is good. So if we really want to say, right, if they are not linearly separable, means I come up with 2 thresholds. Say for example, I come up with a network of MP neurons, okay, that actually gives me 2 threshold to implement this function. So one number for this data point and another number. There is no such function exists for this case, but even if it exists, how it looks like is, instead of having one threshold, I will have another threshold for the same function. So I will have 2 thresholds to produce that function. So which implies that they are not linear.
No, come again, please. Basically, we have only one input, so there is only one neuron.
Yeah.
So one neuron has one output.
Okay, so let me try to explain with two inputs. So if we have two inputs, right?
Okay.
When I say they are not linearly separable, what do I mean by that? Say, for example, even if it is an XOR function, we can't draw any line that
Exactly.
separates all these data points,
Exactly.
right? That is what we mean by not linearly separable.
Correct.
So if we try to implement that XOR function using a network of perceptrons or network of MP neurons, what it actually does to separate these data points? So it draws two lines, right?
No, but why do we implement with network with only one input?
We don't need to, because here we don't need to, because all the functions are linearly separable, because I can find a single threshold that actually implement for each of these functions that implement all these functions. There are no non-linearly separable functions here because it's a Boolean input, right? What I'm saying is, in case even if we have something like that,
Mm-hmm.
in case if we have here all these four functions are linearly separable, so I don't need to. But if there is a function, just for the sake of argument, if there is a function such that I can't implement this function using a single threshold, but I can implement this function fi using two thresholds, it is like implementing the same XOR function with two decision boundaries. I use two decision functions, right?
Correct. Correct.
So I call that as a non-linearly separable data point. So if I come up with two decision functions for the same function, then they are no longer linearly separable. So for one-dimensional case, it's a two thresholds.
That part actually I did not understand. For one-dimensional case, in
Yeah,
one dimension there are only points,
of
right?
course.
The
Single number.
separating thing is a point now.
Yes.
Now the separating thing. So first of all, it is.
Here it is going to be a single number. The threshold is a number, not a line sequence of kind of thing.
So it is a single number.
Hmm.
Now, if we say that is like a vertical line or a slant
No,
line.
you don't try to draw anything there.
There is no line. So it is only a point
So
on the axis.
if you try to extend it to of course, there is a question on this as well. So you can visualize this in 1D, or you can visualize this in 2D if you wish to. Okay, by just bringing this threshold function on the left hand side of the equation, then we can visualize this in n+1. I think I revealed the answer. So is there a question in the graded assignment?
No, this is practice thing, right?
No, I think this is not the answer that I'm trying to explain here is actually, I think I framed the question around this concept in graded assignment. Okay, so I think if it is not a part of graded assignment, I'm happy to reveal that, but if it is part of graded, I have to try to explain
I think
another
it is
way.
not a part of.
Yeah, so suppose that in 2D we are drawing this line, right? You are able to understand it. So once if my input becomes R1, my decision line is not going to be a line.
Exactly, it is a
It is
point.
going to be a single number, a point.
Correct.
The point may belongs here or wherever based on the functions for 0, 0, as you said, the point, all the points after this one, right above one is a threshold.
Right.
Unfortunately, all these functions are linearly separable. So I can come up with a single point such that it implements all these F1, F2, F3, F4 for all these cases, right? For each of these
not single, multiple points I can get.
What you are saying multiple points, I understand. See, if I take this point as a threshold, any point around this is also a threshold.
Exactly. Yeah.
Yeah, that I understand. What I am trying to convey is that if there is a function such that it is not linearly separable,
right?
What I am telling is you will come up with a point here, one threshold T1 here, another threshold somewhere T2.
Right.
Okay. So there will be two thresholds on the real line that actually implements that non-linearly separable function in case if it exists. That is what I am trying to convey. It's
right.
not
So how can we count number of functions now? The question says how many linearly separable functions are there?
Yeah, for all these four functions, if you come up with a number that implement this, if you come up with a threshold that implements all these functions, then they are all, if you come up with a single threshold that implement all these functions, then they are all linearly separable. So when we think about linear, we always think about the line, but when we shrink it to R1, then it's a point. So for all these functions, if you are able to come up with a single number, right? Say, for example, now for 0, 0, you said any threshold after 1 works. So you are able to come up with a single threshold. You can choose any one out of infinite possibilities, right?
Right.
So for 0, 1, can you tell me 1? So my input is 0, the output should be 0. For input is 1, the output should be 1.
Maybe 0 is the threshold, right?
Yeah, 0. So my threshold should be contained within these two, right? 0
Exactly.
to 1, right?
Yeah.
So again, I can pick any one threshold out of infinite possibilities. I can choose one.
Right.
So now I can separate this. Similarly, I can come up with a number that separate this and this. Okay, so now I'm able to come up with a single number for each of these functions, such that that single number actually separate these outputs or implement these all four functions. Only 4 functions are possible when n is equal to 1, and I am able to implement all these 4 functions with a single threshold for each of these functions, right? So I can call it as a linearly separable.
No.
Because,
In the thing we said f of theta is
Yeah.
the function, right?
Of course,
F of
yes.
theta is the function. Now the question says, now number of Boolean functions that can be realized out of one input is 4, that part I understood.
Okay.
Right. Now the question says there is a Boolean function, there is a Boolean function, says how many linearly separable functions are there? So what do you mean by linearly separable functions? Linearly separable Boolean functions, is that the thing?
Yeah, linearly separable Boolean functions.
Sir, can I say just a
Sure,
minute?
please go ahead. So see, in this discussion, so if any of you come up with a different answer, so please feel free to discuss. So there is no such thing like I only need to answer something like that. Maybe I may get stuck at some point. So please feel free to discuss.
So what we are saying that there are 4 functions from 2 inputs, right? 0 and 1.
Yeah.
So out of
one input.
those.
So you are talking to me, Himanshu, or to Govind?
No, to Govind.
Okay.
Yeah, there is only one
So-
input, right? N equal to 1 we are saying. So from the
No, so there
formulae 2 to the power of 2 to the power of n, if we put 1 there, we are getting 2 square. That's called 4 Boolean functions are possible. Those 4 Boolean functions are written by Arun on that slide.
Yes.
Right. So from 0 and 1, we can get 4 functions. And now the question is asking that out of those 4 questions, how many are linearly separable? And since we can linearly separate all 4 of them, the answer is 4.
And also one point might be helpful to Govind is I'm just thinking about this. So when I say the and function is linearly a separable function or not linearly separable function. So if you talk about and function, we can say
Yeah,
it is linearly separable function, right?
Right.
So, but when I say like that, we just out of 16 possibilities, we say the and function is linearly separable, or I can say F8. So I think in the lecture slide, it is F8, I guess. F8 is linearly separable. Like that, we have 14 F which are linearly separable and 2 F which are not linearly separable Boolean functions.
Okay.
So this word linearly separable functions actually says whether the data points are linearly separable. The function has, in this case, 2 points, 2 labels, right?
Yeah. Right.
In the case of n is equal to 1, we have only 2 possible labels. Whether all those labels are linearly separable for all possible inputs.
Yeah, sure. Got it now. All right. Thank you.
Yeah, which is why I said 2 earlier. And if there was suppose n is equal to 2, then we would have given answer as 14. Because out of those 16, only 14 are linearly separable, and XOR and not XOR are not linearly separable.
Right.
Yes.
Right. Okay. Yes, got it.
And also there might some ambiguities. So what happens if n is equal to 0? I think it's a question.
So only one function is possible, and we can
No.
draw infinitely many lines.
We can assume that there is always a bias there in that question, or no?
No such biases.
Because truth table, right? So truth table does not a bias.
So
Yeah.
without input, it is like, is it like don't care or?
No,
Uh,
sir. So there is only one point, right? So one point can be linearly separated in infinitely many ways.
No, there is no point. He's saying no input, right? N equals to 0.
Okay.
Yeah, now you got the question. So now we ran into ambiguities, right? So there we need to, so it's like I don't give anything, but the function keeps on producing something. So the function, it is possible, right? Even if you don't feed any input, even mathematically, it is okay to accept. It's kind of you are passing an empty set as an input to a Boolean function. The Boolean function produces only two possible output. Either it always off or it always on. Of course, I am just mentioning this just to say that. So when we encounter some formula, right? So it's usually when we learn something mathematically, we always try to play with ranges, right? You put it, you move the variable to the extremes and see what happens. So that's what I'm trying to convey here. So this is really helpful. So when you see some functions, of course, in deep learning, functions are functions of many variables, all the functions. So you try to push those to the extremes and see how the entire function behaves.
But function, you are saying any function should have some input, right? So here, when you say there is no input,
it's a kind of no. It is like it is acceptable physically as also without giving an input. The function can give an output, especially the Boolean functions.
No, correct. No, but by the definition of the function itself, we are saying f of something.
Yeah.
But if something is not there, then how can it be a function?
Yeah, that's where I'm saying there are ambiguities around these. When you push the extreme values for the variable, then you will start encountering some ambiguities that could possibly addressed by Simanchko, because they are it's like math people. I think they are suitable to answer this question. But we ran into ambiguities once we talk about these concepts. So the math says you put 2 power 0, then the output is 1, right? Even if you put 2 power 1, the output is 2. There are two possible functions, right?
Yeah.
That's what the formula says.
Right, exactly.
But when we try to come up, can we implement this physically, especially when we talk about these Boolean functions? Of course, it is possible to implement them physically. Even without giving input, I can make the function kind of turn on or turn off. Okay. But when we talk in a strict sense, even if there are no input to the function, so how can the function exist? Then it draws the minds from.
So theoretically, there is an answer in terms of count, but whether it is physically realizable is a different set of questions.
Yeah, that's exactly right words.
Okay.
Oh, sorry.
Sir, but we can realize them in quantum realm, right?
Where
it doesn't.
Yeah.
Where it doesn't have to be a 0 or 1. It can be anything between 0 and 1.
Yes. Okay. So again, I think all the questions are fine. So what I'm feeling is that maybe running through the questions is not a good idea. So let's see for this first time, since it is live streamed, let people watch, and if they okay with the entire questions, practice questions and graded assignment questions, all these things. Then if I don't see any questions in the discourse, then I feel okay, it's all right not to discuss these practice questions and graded questions. But if if I see questions in the discourse, then from the next time onwards, I keep discussing all those questions.
So you're saying unless you unless we put it on discourse, we'll not pick up for the discussion in the live session, is it?
Sorry, unless.
No, unless we put it on the discourse,
Yeah.
we will not pick it up for a live discussion you are suggesting?
No, I'm not saying in that way. So one is that you go, since we are in week 2, all these students might have already solved week 1 questions and also week 2 questions. Supposing that they are watching this live session, okay?
Mhm.
And now I am not discussing any practice questions and practice assignment questions and graded assignment questions, right?
Mhm.
But if I see some questions on it, say for example, after closing this live session,
Okay.
then from the next live session onwards, I keep discussing all these things.
All right.
Because now maybe students are not able to join the session, so that's why they are posting these questions in the discourse.
Mhm.
But if a discourse, if I'm not able to see, I'm sorry, if I don't see any questions in the discourse, then I presume that they are all comfortable with the questions. So not much. I mean, we need not to discuss all these questions because it might be redundant to them to hear. Because maybe they feel everything is obvious. Why we should discuss all these stuff?
All right. Yeah, sure.
Sir, based on my past experience, you will get a lot of questions around the quiz time, even from week 1.
Mhm.
Yeah, that's I'm expecting. Yeah, I think so. When we get a questions, what I'm personally feeling is that, so if you have some questions in mind, right? The only way to get it addressed is either you have to interact to the live session, or you have to put it in the discourse.
Mm.
Okay, so even if we discuss these questions once again in the live session, I'm not sure whether their doubts get cleared up after listening to this live session, right?
Right.
So that is what I am thinking. Okay, that's my thought process on this task.
Sir, it's okay. You can skip those. If you get any request, then you can take up that question in next session.
Yeah, so even if I'm okay to set up on-demand session in case if they really want to solve the problem quickly, they are not able to follow any of the questions, then we can set up the on-demand session and please come and join. We can discuss. Suppose if it is really elaborative, right, to write it down the discourse, then the better, of course, I put it in the discourse, but even if they are not able to get it, then set up the on-demand session and have an live solve with instructor session. It is a kind of case-by-case basis.
Okay, so one more thing I want to bring up, Arun.
Yeah.
So assuming that this is the only deep learning course that we have in this program, because you said the other one is still in the builds and we don't know whether it will be there or not, right?
Yes.
So will there be any help? I think there should be some help for us, in terms of navigating the research papers, as I think Himanshu was suggesting. Because see, for example, in the ML practices course, now when the project we were dealing, there were some problems. We were trying to refer to the papers and trying to get some more insights, right? So can you help us in terms of, from the starting point, like how should we start navigating this research, body of knowledge? Where should we start and how do we know? And for example, if we go ahead and implement them in our real life, what are the quickest way of judging whether this is like relevant to my problem domain or not? How many? So that kind of help, is it possible?
Yeah, I make note of it. So it kind of research guidance, right? So you go through some research paper and see whether
to implement the practical solutions that we are facing in
so
we take this knowledge to the field, and we are faced with the challenge. Now, which one to use instead of just randomly searching in the Google and downloading a PDF, reading through it, navigating through the references that are there in the paper. I don't know what is the best way to navigate. How do you do it in terms of
Yeah, so usually, right, as far as this deep learning field is concerned, it's, as I mentioned earlier, so it's rapidly developed, growing. Even the experts can't read more than 2 to 3 papers a day. That's what Andrew, a professor at Stanford and the creator of Coursera, said. So he usually read 2 to 3 papers. That is even that is sometimes for them it is too difficult to understand even in a one go. Okay, so for example, he said in one of his interviews, in Cornet there is a specific architecture called YOLO. Okay, so that is used to detect objects in an image. So he said after reading this paper 2 to 3 times, he's not able to get an idea how everything works, how everything connected. So it's not quite easy to get because sometimes authors are limited to write stuffs. So if they write it in a blog, they write everything in detail. But if they write it in a research paper, they consolidate and then they look for brevity. They hide lots of details. So that is one of the major problem we encountered few years ago. Okay, but now the trend is, so whoever carry out the research in deep learning, people are started expecting to reproduce the result as soon as possible. So they are expecting the release of the code as well, because 99% of the people do deep learning research in Python using some frameworks. Be either it is PyTorch or TensorFlow. That division is there. But they release their code on a site called Papers with Code. Have you heard of that?
No.
Yes, sir. It's made by Facebook, right?
Sorry.
The Papers with Code is made by Facebook.
Yeah,
As
yeah.
far as I can. Yeah.
Yeah, people from Facebook, I guess. So
What is it? Can you please give the link here, please?
I think you can just type it in Google. I
Yeah,
guess.
just give us give the keyword.
Yeah, in the chat I just put. Yeah,
Yeah.
Papers with Code, I guess.
Oh, Papers with Code. Okay.
Yeah. So here, if you go here, right, you see whatever the model that are, say, in 2 September, some people did some research on diffusion models, and you may already aware of it after going through the brief history about deep learning. So it's very recent research. Of course, you can download the paper and go through it once, but oftentimes you don't get everything straight. Okay, and then you go to the paper and also you can look into the code. So if you see the code implementation of the paper, right, then that is the best way to learn the entire process. You can take a code out of it. Of course, once you understand the foundation of deep learning, like this course, and of course, when you go for this, these are all generative models. Diffusion model is some sort of different stuff. If you understand how those models works in general, say for example, if you understand CNN, there are variety of architectures in CNN, if it is tailored for different applications. So like that, once if you understand the foundation of that field and architecture used for a specific application, then you can, most of the time you can read the paper quickly. If you have a code with it, you can experiment it also parallelly. So this is the best way to understand the paper, especially deep learning, because deep learning, it's a kind of interdisciplinary field, highly interdisciplinary field, because there are people from different background are carrying out the research, and of course there are many authors from different fields, they contribute their own. Oftentimes it's not quite straightforward to understand the entire process. Even I remember I read one paper from DeepMind. Okay, a paper written by an author, a researcher from DeepMind. Okay, you know DeepMind, right?
Yeah, yeah.
Yeah, he explicitly said he has put on a lot of effort on writing the mathematical equations, all these stuff, and sent it to a mathematician. And then he said there is no math in it. Okay, so it's not a complex math, something like that. You can, of course, go through in the Google and you can read his statements. So it's like unless we have, correct background, prerequisite knowledge, we can't understand everything in the paper. But if we have a code with us, right, we can, choose which detail I need to actually focus, which details I need to actually Okay, so that in that way, having a code helps us to reproduce the result as soon as possible. So this is what we do, especially for deep learning.
Okay. Well, some of the papers are behind the access, right? And these are only available through some kind of a login and subscription.
Yeah.
And there are in some of the sites institutional access is available.
Yeah.
IIT Madras is there in the list. So can
Yes.
we have access to that kind of stuff?
I'm not sure about that, whether we can have.
Because probably if on campus, probably we can go to library and get access to such kind of stuff, right?
Yeah, that is the useful thing everyone does. But for deep learning, most of the papers are published in a conferences called CVPR, NeurIPS. They are all, they open source their papers in archive.
Yeah, but for machine learning, I saw some Springer things and all. It is behind the access. So institutional in the institutional access, IIT Madras is there.
Yeah.
But obviously we cannot access them. So if there is any mechanism to access, probably no, we do not know where what paper we'll stumble upon, and if we want to get access to it, probably we'll not be able to do it. So as a student, so is there any possibility for us to access that material if such help is?
Yeah, maybe I ask with JK. Okay, so because this is something they have to answer.
Yeah, sure.
This is a kind
Just
of,
please make a note of it, and
yeah,
if there is an answer that you can provide, that is appreciated.
yeah, I actually asked him. Yeah, I discussed with JK on this point, and then maybe in the next live session I come up with an answer.
Great, thank you.
Yeah.
Sir, also can you pick out some beginner-friendly research papers that we can go through, that you would have done when you were starting with deep learning, right?
No, actually, so research papers of what sense? So as of now, we are just into this week 1 and week 2, even up to maybe after learning this week 3 contents ANN. Then in week 4 we introduce different types of optimization algorithms. Like you already have learned this gradient descent optimization algorithm, right? You will learn a lot of variants of it, especially most of them are suitable for deep learning scenarios. So there, from that week onwards, maybe I can, of course, in the slide itself, for each of these algorithms, I have given a link. So if you open a slide, if you see some algorithm, if you click on the title of that algorithm, it will lead to the actual research paper. So that is how the slide is structured. That is, I ensured, if I'm not wrong, so for most of the optimization algorithm, not only for optimization, for most of the deep learning architectures and whatever on this lecture slides, you try to click on it, see whether it leads to a research paper. Okay, so I have given a link to all those research papers. Maybe from week 4 onwards, you can start reading such papers.
Okay, that would be nice, but I didn't knew at this time. So, also, sir, the books which are recommended.
Yeah.
Which chapters we should go through? Because the book is actually very big.
Yeah. So actually, in fact, the Ian Goodfellow book is the very first book that it's a deep learning book that was published in 2016, if I'm not wrong, right? So since then it was not updated. But for the foundational level course, that is more than enough. I think first 3 to 4 chapters are dedicated to this linear algebra probability, and then important machine learning concepts. Okay, followed by they introduce again this deep learning. So you can start reading from this ANN. They again introduce deep learning in part 2. Part 1, the book is actually divided into 3 parts. Part 1 is all about maths and machine learning, and then part 2 is about deep learning. So you can make use of those chapters. Part 3 is about, I guess, it's a GAN, generative models. So you can ignore that. So we are not exactly following that book as is. We have 3 references, right? One is Ian Goodfellow book, and the another one is the link is there. So that book is actually on the website. I mean, it's an ebook. You can go through it. Again, we are not asking any one of you to go through all the contents of those books. So whatever the content that we cover in the lecture slide, if you see a similar content on those books, you can just refer them. So most of the time we mention the chapters. Say for example, in week 1 and week 2, we mentioned some particular chapters from Roja's book, chapter 1, chapter 2, chapters 6, something like that. But thereafter, we give you a lot of references to research papers. So if you visit Mitei's website, you see there are links to blog articles and then research papers for each lecture lecture contents. So we are not expecting you to go through all of them line by line. Okay, so they are kind of supplementary. So if you don't understand anything in the lecture slide, you may take a look into the references and see whether you are able to grasp that. And even if you don't get it, then we discuss it in the live session. So yeah, so far to this week 2, you refer to Roja's book, and after that you refer to Ian Goodfellow if you want.
So Roja's, sorry, I didn't get the name properly.
Yeah.
Is that provided in this portal? So
No,
in the
not
about,
in the portal.
I mean, in this the link, the details are not provided in this portal, I think. Now,
Yeah,
in the what do you call, like, course, about the course section,
yes.
you've mentioned 2 books. One is Ian Goodfellow's book.
Yeah.
Other is Charu C. Agarwal, Neural Networks and Deep Learning.
Yes.
So the third book, that whatever you just mentioned, it is not there here, right?
Yeah, it is not there in the URL. So you may visit to this professor's site, Mitei's site. Yes, I'm just opening it now. So you can there you see teaching and then the deep learning class he taught at Jan 2022. So there if you scroll down, right, so you see a lot of references to each of his lectures.
No, I think we can't see. I am still seeing the what do you call the course portal.
Is it okay? No,
Yeah.
I did paste a link to the Roja's book. You can check. Also, I did paste the link to Mitesh Kapra's site earlier.
Okay.
Yeah. So now, are you able to see that now?
Oh yeah. Now I'm seeing.
So if you go to his site, you see a lot of references, extra reading materials. Okay, so there we specify the chapter numbers you need to follow.
All right.
Maybe if you're interested, it's not necessary that you have to follow.
Right.
If you're not able to, understand anything from the lecture, if you really want to learn more about it, then you can refer to these references. I think for all the lectures, of course, this is not fully updated because we need to add transformer architectures, all these stuffs. But for the subsequent weeks, you can make use of this site.
So with the transformers, there is no book, is it?
No, it's really a recent architecture. I don't think even there is a detailed explanation on the transformer. Of course, there are really good blogs. We put references to those blogs as well, but it's not covered in book. We have come across one book from Stanford where they talk about this transformer architecture. I think they are, since the field is growing rapidly, coming up with the book is quite a challenging task, because one thing that is most commonly used just 3 to 4 years ago, now it's obsolete, or kind of, it may not be suitable for the very large scale problem. So people started writing their books on the site so that they can keep updating it. You don't see any hard copies that are suitable for deep learning. Maybe it's suitable for foundational level, but once we get into some sort of advanced level, even the transformer architecture is quite advanced. Because it was introduced in 2007, but there are a lot of developments since then. So in such a case, writing a book is not an easiest task. So we will share some references for the transformer architecture soon.
So one side thing. So in order to take this into practice, right? So are these things, is there a way, of course, the frameworks are there, PyTorch is there. Are these frameworks amenable to the all architectures that we're going to discuss? Like, for example, can transformers be implemented using PyTorch and this? And
Yeah.
second question is, are these available on the cloud infrastructures that we have, right? So the Google Cloud, GCP, AWS, are there any equivalent implementations? Because most of them, they trademark it and maybe they coin it as a different algorithm on their platforms. Are there any equivalents from the practical application standpoint?
Yeah. So I mean, see, you can say most of the research developments happens at only few set of organizations. Okay, so they push the boundaries of deep learning. One is, of course, Meta. The another one is Google. Then OpenAI. So all these people are pushing the boundaries of deep learning, and you can rely on them. PyTorch is supported by Meta. Now it is come, I think, just few days ago. Now PyTorch came under this Linux Foundation, which is completely open source, and they keep developing it. So to answer your first question, you can implement any deep learning architecture using PyTorch. Okay, so even there is another field called graph neural networks, which is quite completely different from that we learn here. Again, PyTorch supports it. So I would say you pick either PyTorch or TensorFlow, because one is supported by Google, the other one is now supported by Meta and other NVIDIA, all these guys, right? So in both of these frameworks, we have functionalities or API to implement all these, as far as I know, to all the deep learning models. But the problem we face is that if you really want to implement the deep, say for example, you can create any architecture, deep learning architecture in PyTorch, but can you train it for a large scale data? We can't do like they do. Like, say for example, transformer is used for natural language processing, where they train it for a month. So after training the transformer, they release their model to the public, so we can make use of it. If you really want to implement the transformer architecture and train it on a small data set, we can do that with the help of PyTorch. So in a summary, we can pick either PyTorch or TensorFlow. We are following PyTorch. So you can implement any architectures using these frameworks. The other question is, do we have an implementation? I mean, can we use these frameworks on cloud platforms like GCP and AWS? That is what you are asking about, right, Govind?
Yes, that's correct.
Yeah, you can implement. So I have seen people, I mean, even I have implemented some of the stuffs in AWS, Amazon Web Server, and also it must be there on GCP, and also this MXNet from Microsoft. So they are all supporting all these frameworks. I mean, you can directly import, like we do it in Colab. They provide a machine for deep learning, tailored for deep learning. So you can import all the frameworks there. You can simply train it.
All right. Yeah. Thank you very much.
Yeah. Okay. Thanks a lot. I think many have already dropped. And let's see. I create a WhatsApp group and then put it in the Discord. Invite link in the Discords. And also, if I get your numbers, I send a direct invite to you all. But you look into the Discourse and see the link, and if you get an invitation with the same link, then you join that WhatsApp. Let's meet each, one of our colleagues or students, whoever.
Classmates.
So it's a kind of mix. Yeah, classmates is the awkward.
Yeah.
Okay, thanks. Thanks
for your patience.
Bye.
And
Yeah.
Thank you, sir.
it's been very
Bye.
good
Take care.
Yeah, bye.
knowing you. Thanks.
Sir, before going on,
Yeah.
how much, what do you think, how many students will join in the next session?
You're asking me to predict.
Yeah, just a random guess.
I think if the material gets tougher, people will join maybe.
Yeah, given that it is week 3, right? I'm going to see some questions in the Discourse, and also many people will join in the Okay, my guess will be since there are 55, around some 25 plus may join, given that it's a week 3 contents. And of course, the questions are quite tough. You will see around some 7 questions in graded assignment and practice assignments. But the thing is that you should know the entire stuff in order to solve those questions. And we are asking you to write a small piece of code. So given all these complications, many will join.
But do you think 1 week will be sufficient to pick up on the entire week 3 material?
Of course, it's not too much difficult. In fact, the thing is that if you look at everything as an equation, right? So you, in fact, everything is just an index. This is a hint for you. I mean, you can make use of this. You will see I, J, K, so many variables there, but all of them are just referring to, index of some number in a vector or in a matrix. Okay, so but at the first sight, you see everything is kind of intimidation. But if you don't understand one step, okay, don't go to the next step. That's my hint. So you don't think, let's watch the entire lecture once, and then if you don't get, and then go and solve the assignment questions, you will definitely get stuck if you don't understand the entire process. Because the questions are, I'm expecting you to write a code because it's a very simple 3x3 matrix, but we don't want you to work out all these calculations. So you are supposed to write a code using NumPy alone. And if you know how to make a matrix vector multiplication, that is more than enough for the entire implementation. So given all these, circumstances, now we are pushed to the boundaries. So you have no other options because there are only 7 questions. And out of the 7, last 2 questions, we have given a high weightage for those 2 questions, which actually ask you to compute the backpropagation. Okay, so you can do forward propagation. That's not a big deal. Everyone is comfortable with that. If you take 100, so if there are 100 students, if you ask them how comfortable are they with the forward propagation, all 100 will raise their hands. But if you talk about the back propagation, maybe you see many drop their hands. Okay, but we don't want to happen here. Maybe because given that you are from diploma level students, you are equipped with all these skills, so you are expected to solve all those things.
Okay.
And so while you watch lecture, please do not go to the next step if you don't understand the previous step fully. Okay.
Okay, thank you. So will there be any session for the AI also? Do you have, maybe you can communicate with them and at least they can make some communication?
Yeah, sure. I convey it to JK. So he's a odd person to communicate with them. So I don't have a direct contact with the course instructor of AI, but I convey it to JK and he might convey it to the.
Yeah, sure. Yeah, that will help.
Yeah.
Sorry to actually talk about other course. But...
No, it's not an issue. So right, it's not a. So you
also right. Also, sir, the calendar for deep learning is showing in the AI calendar, so there might be some errors there.
Yeah, I communicated this to the support team. They are looking into this. I don't know whether it get resolved it or not. So you are still seeing this,
yes, sir.
Training calendar in AI. Okay.
Yeah.
Maybe they fix it on Monday.
Right. Also, sir, how to approach week 3? First, I should go through the lectures, and
First
then start.
Yeah. Ensure that you understand every step. Okay, so do not. It's most of the time while we listen to the. Okay, it includes me. While we listen to the lectures, that is completely new to us. We we simply overlook it, right? So we assume as if we understand every process, and we just keep watching it. That won't help in this case because given that you need to implement back propagation in order to answer some of the questions in graded assignments. So I'm just suggesting if you don't understand any single step, do not go to the next step. If you do so, anyhow, you have to come back and watch it. So it's a kind of cycle until you understand the entire process. At least even if you don't know the entire details of deriving the back propagation algorithm, you should know the final formula at least. Okay, so again, this is a kind of pleasing words. Okay, so if you even if you don't know the entire process involved in deriving the problems, you will see some pseudocode at the end. You should know at least how to compute that. So that is extremely essential. So ensure that you understand all these things. And even I would suggest, okay, this is the one suggestion. Then you make your decision on your own. And if you stuck at any point, make use of the discourse and watch these videos as early as possible. Once you submit week 2 assignment, and start watching these videos, week 3 videos, because I'm sure it is going to take a lot of time. Okay. And professor will also keep implying that, keep saying that in the video. Pause it and ensure you contemplate, reflect on it, ensure that you got everything, and then move on. Okay. And make use of the discourse. I try to answer the questions in the discourse. So if I feel something is not possible to answer in the discourse, then I may set up an on-demand session.
All right. Yeah. Thank you.
Yeah. Okay. Thanks for joining. Bye.
Thanks, Arun.
Thank you, sir.
See you next week.
Yeah. Bye.
All right. Bye.